Good morning. I was going to do this yesterday when I was we're already wearing a suit for the conference, but I didn't get to it. So, hey, anyway, there are a few additional points that I wanted to cover with you before we get to the end of the course, and regression to the mean is one of them. So, why is this important? Well, this is my lovely daughter and her husband, who is 6'7", and the boys who are 6'5" and 6'4". So Travis is really tall, and the boys are also really tall, but not quite as tall. And that is a perfect illustration of regression to the mean. In brief, extremely high scores or extremely low scores on X, whatever X happens to be, represent a situation when all the factors that determine X combine to favor one outcome. And if that's the case, if we're predicting something else, Y, whatever it is, it's not likely that every possible factor is going to come out in the same direction. So if something's extremely high and you're predicting from that, the most probable result is the thing you're predicting is going to be higher than its mean, but not as extremely high as X, where you're predicting it from. So let's take height as an example, because it's a very common example. Uh, there's multiple genes that determine height, right? You get some genes from your mother, you get from your father. There's genes that cause genetic disorders, in which case the child may be smaller. So there's multiple things. Then there's the prenatal environment. If your mother does not have adequate nutrition during pregnancy, as we saw from a lot of examples during World War II, when there was a shortage of food in areas, then your height may be smaller, well, shorter. If you yourself don't have adequate nutrition or you become ill, that can also affect your height, which means that a person who's extremely tall must have scored high on all those factors. That is, they got the genes from greater height from both parents, they didn't have any genetic mutation, they had good nutrition throughout pregnancy, in utero, throughout childhood, they didn't have any severe illnesses that would have impacted them in childhood. Now, what does this regression to the mean have to do with education? It's kind of a ubiquitous factor, regression to the mean. And it says this in your textbook that people with high scores tend to be above the mean in skill and in luck. So not only are you more knowledgeable about biology or mathematics, not only are you smarter than the average bear, but you also happen to study the night before the test, unlike some other nights where maybe you went out with your friends, but just by luck, you happen to pick that night to study, or maybe some of the questions you didn't know weren't asked, but the things that you had studied, maybe the only things from the first half of the textbook, and you'd only read the first half. So people with high scores tend to be above the mean in skill and in luck, and people with really low scores tend to be below the mean in both skill and in luck. So the student who has the lowest score, they may not be the brightest crayon in the box, but they also perhaps uh, had a really rough night the night before, they were sick today, whatever. And so because of those bad luck factors, they also didn't pay as much attention, they weren't thinking as well, and did poorly. But only that skill portion is relevant for future performance, right? Because luck, by definition, is random. Now, here's an important point that comes from me that's very related to that. If you try an intervention with a class of the lowest performing students in a district, which is often what we do, the next time you test them, regression to the mean is going to predict that the scores of that group will go up, which is why you should always have a control group because you want to take two or three classes and see if the ones that get the intervention improve significantly more than the ones who are in the control group. This also applies to coaching. that people with high performance tend to be above the mean in skill and in luck. And if you look at page 458 in your textbook, there's an argument where somebody is saying that praise doesn't work and punishment, yelling at people is more effective because when pilots did extremely well and he told them how great they were, they tended to do less well the next time around. And when people did extremely poorly and he screamed at them, they tended to do not as poorly the second time around, which would go exactly whether you praised or screamed them, along with what we just said about high scores and extremely low scores have factors of both skill and luck, and that only the luck part is going to be replicated. And let's go back here where I said you should have a control group. If you have an intervention with the class of the lowest performing students, even if you have a control group, you would presume that the lowest performing students, because just bad luck, did the worst on the test. I mean, it was only bad luck, but that was one of the things. So what you should do is you should take a random sample of the students, not the lowest performing students, and put them in the intervention group and in the control group, and then see if the intervention does have a significant effect. So your that's a whole nother topic, but your control group and your intervention group should be as close to identical as possible, with the only difference being the intervention. So anyhow, that is what I had to say about regression to the mean. It applies to lots of things, to height, to performance on educational test, to performance in athletics. So think about that.